In this video tutorial, we'll take a look at how to use HLSL and custom nodes in Unreal to distort the UV coordinates to create interesting and abstract patterns as shown here. These patterns can also be animated with time and produce some very unique effects. We'll start off in an empty material and we'll create a custom node. And we'll connect this custom node up to our base color, and inside that custom node we'll have to add some code. Now for the code that we're going to add, all we really need to do is be able to have an input of a texture object. So if I right click and create a texture object where I could select a texture, and maybe for an example I'm just going to select the 1x1 grid texture here. And I want to be able to connect that up to my custom node and have it output. Right now it's just outputting white. It's not actually outputting this texture object that I've plugged in, because we have to sample that texture and return it to output it. So I'm just going to open up Visual Studio Code so we can see the code a bit better, and we'll do something like this. We'll define a float 4, so that's a number or 4 numbers packed together, red, green, and blue, and alpha. And we'll define that as color, and we'll make that equal a texture 2D sample, and we'll call it texture object. That'll be our input, and we'll create texture object sampler here, and then the UV. And then we'll just return that texture 2D sample that we created. So we'll just return color. So that's really all. If we take that code and we go back and put that into our custom node, and then we define our input. So our input will be texture or text object. And then we'll add one more input for UV, and we connect the UV up to a texture coordinate. We now can output that texture. We've created a texture sampler or texture 2D sample that samples this input, and then we return it. So now that we have that done, we can start actually making things that will allow us to distort or deform or transform this texture in different ways. So it might be nice to be able to scale this texture to a smaller size or to a larger size. So we've looked at this a little bit before, but I'm going to go back to my code here, and I'm going to add on a function. So I'm going to create a structure, and I'm going to call it texture distort. And inside of that, because we have to wrap any function inside a structure within these custom nodes, otherwise it won't work, it'll give us an error. So inside that structure, I'm going to put a float2. So float2 because essentially it's going to be used for UVs. So float2, 2 numbers, U and V. So the U and V coordinates. And I'm going to make this function called maybe something like texture scale. And I'll take in a UV and a scale value that determines the scale, float2. So two axes, U and V, and I'll call that scale. And we'll use those 2 inputs, the UV and the scale, to take the UVs and scale it. So we'll take the UV, so I'm going to create a new variable called texture scale. I'll make that equal the UV minus 0.5, and we're doing minus 0.5, and we're also going to do plus 0.5 over here, so we're scaling it from the center of the UV. If it was 0, 0, it'd be like the top left corner. If we do 0.5 and 0.5, that's right in the center. So I'm going to take the UV, and I'm going to scale it, and then have these offsets, so we're scaling it from the right point of the texture. So it's not scaling from the corner or anything, it's scaling from the center. And then we'll return that. So we'll return this texture scale. So it's going to take our texture scale, or create texture scale variable, make that equal our UV, and scale that texture from the center point, or from the offsets here that push it into the center point. And then we'll return that scale, and that texture scale will end up being our newly distorted or modified UVs that will successfully scale that texture. So after I've made this struct, if I really want to test this out, I have to go down here and take our structure and just give it some sort of name. I'm just going to call it TXD for texture distort. And if I want to use it now and properly see this work, I'm going to modify what I return here. I'm going to return color still, but instead of having the color just be our texture sampler and the UVs, we're going to take those UVs and we're going to distort them. So I'm going to use my function here, texture scale, and put in those UVs and scale it by 2. So I'm using 2 for the scale value here. And what that's going to end up doing is scaling the UV, or almost tiling the UV, kind of twice the size that it currently is. So if we do that and we take all this code and we put it into our custom node here, there we go. Now we're scaling it down. So if I change that scale value, if it's 1, it's our original. 2, it's smaller. 3, it's even more tiled, and so on. So now we have a function to scale our UVs. Now that's very simple. So maybe something that'd be also useful is to be able to rotate the UVs, to be able to rotate this either clockwise or counterclockwise with a certain amount of degree or rotation. So if we want to create a rotate function, we'll do float2 text rotate and do float2 UV and then float angle for the angle we want to rotate by. And then what we're going to do is define how we're going to rotate our texture. So to rotate our texture, we're going to have to create a 2x2 matrix. So we'll do float2x2 and we'll call it maybe something like rotation matrix. And what this will do is create pretty much 2 rows, 2 columns. It'll create a matrix of pretty much 4 values is what it's going to be doing. So by doing this, we'll be able to define how it should transform the coordinates to pretty much do a rotation or perform a rotation. So we're going to do float2x2, and to do a rotation, we're going to do cosine angle and then sine angle, and then I'll format it this way so it resembles that 2x2 matrix. And then we'll do negative sine angle and then cosine angle. And that will do a clockwise rotation. Now, if we were to take this sine angle and get rid of the negative there and add it here, what that essentially would give us, if we had this sign be negative and this sign not be negative, that would give us a counterclockwise rotation. So you can change between which way you want to rotate. I'm just going to leave this one as negative sign so we get a clockwise rotation, but that's how you can kind of flip that around if you needed to. Now, how do we apply this rotation to our texture? Well, we'll have to return, but we'll have to multiply this matrix by our texture. So we'll multiply our UVs. So not really texture, but we have to multiply this by our UVs, and the UVs determine how the texture is aligned. So we'll take our UVs and again offset it by minusing 0.5 and then multiply that by a rotation matrix. And then after all that, we'll plus 0.5, and that'll just keep it rotating around the center point of those UVs. So it's not rotating based on the corner or some other position. It's going to rotate that texture from the center point of the UV. And now we have this function complete. So if we want to test this out, we can go down here and instead of texture scale, we can do text rotate. And we'll take our UVs. How much do we want to rotate it by? Now this won't be degrees. If I do 360 degrees, it'll do a full rotation. But this is going to be accepting radians, not degrees. So if you want to use degrees, you're going to have to convert those degrees to radians. And you can do that by using this radians function like that. And then it'll take this 360 degrees, convert it to radians, and use it within our texture rotate function. So if we take all that and we copy this and put this into our custom node, texture looks the same because we're rotating 360 degrees. But what if I rotate 45 degrees? There we go, 45 degree rotation, or 15 degrees. there's a 15-degree rotation. So now we can rotate our texture. So after doing that, now that we have this rotating being able to work and be done, we can have that rotate based on time, and over time rotate more and more. And then we can also add distortion to our UVs, which is what we'll do next. So if we want to add distortion to our UVs, now we can rotate, we can scale, but what if we want to add some major distortion into it? Well, I'm going to go back to the code. And what we'll take a look at next is adding one more function. So I'll create another float2, and again float2 because it will control the U and V coordinates, both directions, both values. And I'll call it text distortion. And again, I'll take the UVs, and then I'll take a time value. Time value will have it animate or change over time. In this function, I will define the angle. And this angle is going to be using a tan 2. And I'll take the UV coordinate y minus 0.5, our offset, and UV coordinate x minus 0.5, offset. And I'll define another variable called a radius, and that'll be the length of our UV minus 0.5. And that'll kind of give us almost circular-like patterns. And then we'll do the distortion, so I'll do another variable called distortion, and that'll be 4 multiplied by sine, 3 by a radius, maybe plus 2 times time. Now what is this actually doing? Our distortion, if we think of this, it's pretty much being able to define the frequency and the speed and the time. So what's actually going on here is we're pretty much this defining the magnitude. This value here is defining our frequency. This is our radius. This is our speed multiplier. And this is where we get our time, the value that's constantly changing. So magnitude, that's like strength, frequency, and speed. So you can replace those numbers with variables if you want to add them up here to have different variables or inputs to control those things like magnitude, frequency, and speed. So if we take something like this, it's going to distort our texture quite heavily with these settings. So if I return, and I return that distortion, and maybe we'll make this distortion spinning, so we'll do our texture rotate. We'll use our texture rotate function here, and we'll do our UV, and then we'll use our distortion for the angle. Oops, distortion. And down here, instead of using our rotate function, we're going to use our texture distortion, and then UVs, and then for how we are going to use our time here, we have our time input for this function, and again, time is going to control this part of this little formula here. So we'll put in our time function. I will need a time input on our custom node, so I'm going to take all this code, put it into Unreal. We're going to get error because it's going to need a time input or a time variable defined. So I'll add another input. I'll call that input time, and I'll connect it to time. And now if we look at this, okay, kind of interesting. We get this pattern. It's a grid, but now it's spinning and distorting. And as we increase those values, so that 4 number that I had was magnitude. If I increase the magnitude, you can see the intensity becomes more. If I decrease the magnitude, then it's not as much distortion. So you kind of have control over this to play around with those and change the way it distorts. And even though this is pretty cool, we get some pretty interesting distortion, we might want it to have more of like a kaleidoscope effect to really start to distort more parts of this. So I'm going to go back to the code and add one more thing here. I'm going to add one more layer of distortion. So I'm going to create another variable, float. I'll call it maybe prim distortion or prim dist, I don't know, we can call it whatever we want. And I'm just going to make it a sign. And then I could define a number, which will be kind of like the intensity of this effect, or how many times it almost duplicates the pattern in a sense. So I'll do like 6 for now, times angle. And then what I'll do is times that by our distortion. And instead I'll use that. And if we take this code now and put it in here, we're going to be getting some really heavy distortion now, like this. And if we change that number from 6 to 2, then not as much. If we leave it at 1, kind of mirrors the effect. But if we put it at something like 12, then it kind of duplicates that effect all around. It's multiplying, almost like scaling it in a way. So we can start to really create some interesting effects now, just using some simple math and some simple distortions on our UVs. Now, if we look at our final code, the way to summarize really what this distortion function is doing is we first define our angle. And our angle here, the A10 to UVY minus 0.5 and UVX minus 0.5, this is essentially giving us our angle from our UV coordinate to the center of the UV space. And then our float radius, length UV minus 0.5, this is giving us the distance from our UV coordinate to the center of the UV space. And then our float distortion is pretty much doing a wave pattern distortion using the sine wave, where 4, again, is our magnitude, 3 here is our frequency, and 2 is our speed, or like a multiplier for our time. So those 3 things are adjustable to create different patterns. So that's creating most of our distortion. And then what we do is we do one more layer of distortion, which takes our angle from the center of the UV, from the current point to the UV coordinate to the center, and we're multiplying that. And then we're timesing that by our distortion. So this is acting as a second level or a second layer of distortion. So you can easily layer more and more distortion, but you have to be careful that doesn't become too noisy or just too crazy. Otherwise you'll lose a lot of those details. Now, if we want to take this one step further, we can have textures like this that kind of are mostly procedural in a way. We can input a texture, we can distort it through our code, through our functions, and then we can Raymarch it in depth. So we've Raymarched things before in our previous video, but if we want to do that with this pattern, what we could do is go up here, define a float3, which will be our ray step. It'll take our view direction, we'll have to create a variable for, times that by -1, and then I'm going to define our color variable, and down here we're going to take our color. We don't need to define it anymore here, but what we're going to do is put it into a for loop. So I'll go in here and I'll do for, and I'll do int I equals 0. And if I is less than 5, that's the number of slices we're going to draw. So we're going to draw 5 slices in depth. I++. And then inside this for loop, we'll take our color pattern, our distorted UVs of our texture, and our texture's result, and we'll check if each of the pixels are brighter than a certain amount. So we can modify the color or clip them out or do whatever we want. You can do this in many different ways, but I'm just going to take the color red, color green, and color blue and check to make sure they're bigger than 0.1 in terms of brightness or luminance. So there we go. And then inside that, If that's all true, we'll return the color. And at the very end, we'll have to step slightly into depth. So we'll do our ray step times 1.5. 1.5 will be how far the gap is between those different slices. We're only drawing 5 slices, so I'm going to make that gap pretty large between those slices. And this is really it. And if we take all this now and we put that back into our custom node here, we're going to have to add another input for our view direction variable. And I'll connect that up to the camera vector world space. And now we're Raymarching it in depth. And it looks like it has this 3D animated vortex or tube-like effect. So that's pretty cool. And then we can go in here and change the distortion, change the pattern. You know, if I want to change the texture, sure, change the texture. Let's see. Make sure it's all updates. You can't really see this one because everything is greater than that value of 0.1. So maybe we'd have to change the threshold here. We can see if it's lower than a value of 0.3 or something. There we go. Now, what you can also do, I'm going to go back to this, and maybe I'll jump back to the code here because this looks a little bit boring. Instead of just returning the color, we could return the color multiplied by a float 3 with a red value. And that will take the white areas, or the areas that are brighter than 0.1 in luminance for red, green, and blue, in that texture object or in the result of our color, and it will multiply it by a red color to tint it. And if we do something like that, and we paste that in here, now what we're going to get is a lot of these tinted red. So if we go back to our code, we can also do an else if color red is bigger than 0.01. And I'll just copy this to make it a bit easier. So if red is bigger than 0.01, green is bigger than 0.01, and blue is bigger than 0.01, then maybe instead I'll return the color times a tint of green and blue. And by doing that now, I can threshold out different brightness values of my texture. And let's see, I got an error here. What is my error? Oh, my bad. In HLSL, it's else if, not elif. And if I do that, there we go. Now we get a mixture of blue and red, and you can threshold out these different values however you want. And we can put that into emissive as well, just so it kind of glows. Maybe it looks a bit more interesting. Maybe if I don't like that blue color, I'll make it like 0.5 green and 1.5 blue, so it gets even brighter and more glowy on the blue areas. And if I copy and paste that in here, maybe a bit more interesting. So you can kind of play around with this, create some interesting patterns that kind of get Raymarched in depth. It just gives you an idea now and some ideas of how you can start to add animation to these patterns that you Raymarch to really give something more interesting. If you enjoyed this video, if you learned something new, make sure to like, subscribe, press the bell button to be notified of future videos. And if you are part of the Patreon, which you can check out in the description below, you will also get access to the PDF for this video, which will go over all the steps that were covered in this video in a little bit more detail. So you can grab that if you're part of the Patreon, and let me know in the comments below what interesting patterns you created, what formulas you used to create those patterns, and what videos or what content you'd also like to see next.